Then it will provide you with an indication of what type of resolution of topography or other types of data that's available. I want the high resolution topography, and I'm going to download the 2024 update. Here's the section that I've chosen. Here's the northings and eastings, or the X and Y coordinate values. The file format, LAZ. BricsCAD is really powerful because it will bring in numerous file formats. I add in my email address, they send me a link, and now I can import this into BricsCAD via the Point Cloud tab. We get an import attach. We can process a file. We're going to start with the LAZ file format, but if you're working with E57, LAS, HSPC, all of this data natively can be loaded in instantly and processed inside of BricsCAD. It's geolocated, so I don't need to change the coordinate system. I attach it, it's processed, and here we have an exceptionally large point cloud with millions of points working perfectly inside of BricsCAD Pro. Next, I want to look at the data and make it more visually understandable. So I'm going to go to the color map and choose the classification color scheme of LiDAR or 3DR. The LiDAR classification scheme will color code it so I can better understand the ground, the buildings, the vegetation. And in the Point Cloud Manager under render settings, all my classifications are shown here for me to turn on and off. So if I don't want the noise or unassigned or low point showing, I can turn these off in the Point Cloud Manager under the classes. And here we have a large chunk of the Auckland CBD and the lower shore area, including highways, waterways, the Sky Tower, detailed vegetation, low vegetation, ready for me to use inside of BricsCAD. The next step here is we'll look at how we can convert this detailed point cloud information into a tin surface. If you need to, you can also use other tools to crop the data. You can crop internally, you can crop externally, you can adjust the amount of points, you can adjust how it fills the gaps and turn on and off the classes to set the information you want. So to do the tin surface from the point cloud, we'll turn everything off except for the ground, and we'll leverage that to create our tin surface and contours. Now, if we're working with other BIM packages like Revit, we want to make sure the coordinate system is aligned. So BricsCAD works with real-world coordinate systems. We've set up our GIS information, but we might need to collaborate with a structural engineer in Revit. We can use the BricsCAD file inside of Revit to acquire the coordinate system and move the survey point and the base point to align with a specific point inside of BricsCAD to make sure that both data sets are aligned. So here I'm simply just choosing a point inside of BricsCAD, and I just want to identify my eastings and northings. So my eastings being my X direction and my northings being my Y direction. I can go into Revit, go to the site view, and by default, the survey point and the base point are set to 0,0. I want to set these to the same northings and eastings as in BricsCAD. I'm going to enter these in with the clip unclipped and make sure they're entered as meters, and that will now move the survey point to the exact same northings and eastings as per my BricsCAD file. I can link in and align that BricsCAD file into Revit, and I can see it's coming in at the exact location. Now, the Revit engine is a little bit different to a CAD engine, hence why graphically it might look a little bit offset but technically it is aligning everything perfectly. The walls here we're doing in Revit are skewed a little bit, and that's because of the way the Revit engine works when you move the survey point to a real world coordinate system. But to test this, we want to sync this data back into BricsCAD. So we recommend using an IFC file workflow where we can export out an IFC just using the standard settings and then link or insert that back into BricsCAD to check that the Revit BIM data is aligned correctly with the BricsCAD survey data. So here I'm choosing to import it. The reason I'm choosing to import it as opposed to reference it is I want to show you that the IFC data from Revit is visible as information inside of the BricsCAD engine. So the data comes in perfectly, it reads correctly, it's not skewed, and the information from that database is visible and usable inside of BricsCAD. Now, for collaboration here in the Australia, New Zealand part of the world, the construction cloud is heavily used. So BricsCAD can benefit from using the construction cloud via desktop connector because it is a CAD-based platform. All we need to do is install the ACC environment, the desktop connector, and we can save directly from BricsCAD into Construction Cloud and collaborate with other consultants who have been mandated to use that platform. We can also load other file formats like image files or even HSPC files should we need to have that available in the CDE. So the workflow we have here is simply just saving the BricsCAD data as a CAD file directly into the Construction Cloud via the desktop connector. I don't need to do anything. I just need to save it as if I was saving to a network drive. I've installed the Docs environment, the Construction Cloud engine, and here we have accessible all the files that are available in the Construction Cloud. I simply save it as a CAD-based DWG file, and this will now process and be visible inside of ACC. It's viewable in both 2D and 3D. The layers come through. I can turn on and off the layers as desired. You can see the tin surfaces come through, the contours have come through. And if I want to turn off these layers and inspect the metadata behind that line type, it's showing here. So there's no restrictions in terms of you working and collaborating with other users on the Construction Cloud using BricsCAD, working in both 2D and 3D to see the data perfectly aligned and ready to collaborate with other packages. A tin surface I've created with the contours, with the minor and major intervals showing. The IFC Revit file that I brought in is available here, perfectly located. And of course, metadata is associated with this file as well. So now that we've gone over some of the data sources, and there are more, you can bring in spreadsheet information, CSV files, other data from Civil 3D applications. You can bring it in, set it up, and then start to use this data to generate your site. So we're going to look at a couple of examples of generating tin surfaces using point clouds and contours. We'll then highlight how you can customize the amount of detail in the triangulations, refine areas as needed, and attach the geolocated aerial imagery to that tin surface. So here inside of BricsCAD, I want to look at some of the tools to create a tin surface. The first one is bringing in a CAD file with the topo lines that are set to the Z values can be brought in. It's geolocated, and we can simply use this information to generate a very detailed, accurate tin surface off that data. BricsCAD, like any CAD platform, will work with your layers. You can isolate, freeze, lock layers, and then we want to create a tin surface from contours. Grab the contours, and it will now create a tin. We're just going to use the default settings in the command prompt. And here we have a highly detailed tin surface generated from that CAD topography. Now, because we're really powerful with point cloud data, we can bring in that point cloud data and again use the classification system to turn off the information we don't need so we can generate a tin from the ground point cloud data. So again, I just hit the tin surface button. I choose create from point cloud, select that point cloud, and then there'll be options to simplify it, adjust the elevation information, and it will generate a basic tin surface. Now you can go further with this with simplifying or densifying the tin surface, or even choosing part of that tin surface and densifying a certain section derived or indicated by a closed polygon. Also, with our Civil Explorer, this is where you're going to find the generated information. So our tin surface can be turned on and off like the GIS data, but we can also go into more tools to extract the data, add, edit, remove points, and modify it as per our preferences as the project demands. Now, BricsCAD is really powerful for CAD documentation. And with the BricsCAD Pro environment, you can leverage the Esri shapefile attributes to automate some of your documentation. The one I do want to show first is the point styles, how we convert point styles into CAD points, and then we can edit and label those symbol styles and customize them as per our company drafting standards. So in this file, the points that have come in that represent the stormwater manhole and chamber pots are just shown as dots. They're very hard to see, and we want to convert these to symbol styles. So I'm just going to turn off some of the layers and grab those points and convert them to CAD points. So simply we go to create civil points, select all entities or grab them on the screen, and then make sure they're on the right layer. So here, these by default have gone on to my layer 0. Not a problem inside a CAD application. Just simply isolate that information. So select similar and then turn off the layers you don't need. And then we can put these onto the correct layer, which is the stormwater, manhole, and chamber pot. So this is the default symbol style. Now this is 2D shape data. Therefore, the elevation information isn't just showing a 0,0, but it is showing the numeric information based on numbers of points. The simple example here is we can go into the symbol style, which is set to default, and edit it or duplicate it to create one that's more customized. And we can do it via the properties, or we can do it by the powerful Civil Explorer. I've gone in via the properties, and I want to change the symbol style to stormwater manhole. I could create it from a block. So maybe you've got company standards of a block that you want to use, or you can just use some of the tools like the circle frame or the square frame with an X mark inside of the BricsCAD symbol style editor. You can see there's a variety of ones to use from. You can change the scale, you can change information about the layers, And you could even get into the code blocks should you want this to represent more about the label style. Again, a very simple and powerful workflow to convert points, shape points, into CAD data and then annotate them quickly across your documentation. Now, the same principle going to apply to line and label styles. So in this instance, we want to get some of the lines and start to add annotation and arrows to it. So we can use the code data embedded inside of the shape files and use the code block inside of the label style editor to annotate these lines. We don't need to manually do this. We can save it out as a template for use on other projects, and we can do this on numerous entities throughout the project. You can add prefixes or suffixes as needed, and you can do this as well for borders and parcels, areas as required, cadastral information as well, which we'll show after this line work demo. So in the GIS data, I have the line work representing the stormwater pipe, and I want to add some line style editing information to it. By default, it has some of the cadastral information, the bearing and the distance information. I'll delete that and create some new ones from scratch. I want to extract information here from the stormwater pipe information that says SW_pipe. I add that property, I search through this data, and then I can add that as a code block inside of my label style editor. I can also use annotation data like an arrow to show the flow of the water. So I can choose the style, could be a dot, could be a closed arrow. You can choose the colors, the layers. And when you apply that to all of those stormwater pipelines, it will annotate instantly. So I'm just turning off the other layers and going to my line and label styles. I want to choose the stormwater pipe label style I've created, not the default one, and choose all that line work. And now instantly it's gone and annotated it for me and added some arrows. So we're off to a great start, but maybe we want to adjust it. I simply go to the Civil Explorer and I can change the arrowhead size, the rotation, the length, the Y offset, and you can see it updating in real time within the BricsCAD environment. So again, this is a really powerful tool for you to set up in BricsCAD, use as a future template, and save numerous hours when doing your documentation. We can do the same with area labels, but there are a few more tools here to show more information about the lot. In this case, we're going to be doing a deposit plan here in Australia. In New Zealand, it's the Land Information Act. This can all be customized and adjusted as we change scales in our drawings. And this can be done with numerous different code block tools inside of the label and line and editor tool inside of BricsCAD. So when I go and select the parcel information, a lot of data is available from the council. I want to go and set up a new label style to capture information about this parcel. So I'm going to do this one from the Civil Explorer environment, and I'm going to call it a new name, put it on a layer, and then use the length and area code blocks, delete the length, and work with the area. But I want to add a bit more information from the shapefile. I want the parcel description, and I want to give it a prefix. So I want to call it DP, and for the area, I want to give it a suffix, meters squared. I can simply do that inside of that label editor via the Civil Explorer, and then choose some plots to test it on. So out of the box, we've got a quick tag. We want to modify this. We simply go into the object name and choose the parcel information we want there. We can adjust the way we want that text to look. So maybe we want to have a border around it so it's more clear on our documentation. Maybe we want to have a semicolon and a space between that information, a larger gap. We can do this all to get that annotation looking a lot more clear for anybody receiving the documents. We can also make it even more clear by adding a curved border and adjusting the scale. So as we change to a scale that might be more realistic for a large chunk of land like this, like 1 to 500, 1 to 1250, that intelligent annotation will change as well. Now, for boundary data, doing your cadastrials, we can quickly set up your bearings and distances. There is a very powerful transparent tool for doing bearings and distances inside of BricsCAD. We're just going to be leveraging the data. We don't have to necessarily draw this because all this data has been provided for us by the council. It's really powerful for complex boundaries. And again, we can adjust this really easily and quickly to suit the documentation output required. So if we go and choose a line label style to edit, we're going to work with the default one, which has the built-in parcel information. So this is one I made before. I called it boundary, but this will have your bearings and distances available. So I'll just select one of these parcels. Has a lot of vertices and vectors in it. So it's giving us our distances on each one of those bits of line work for the cadastrial. And here are the code blocks that allow you to edit that information and customize it for better documentation. So under the bearings, we have this bit of information, and under the distances, we have the information capturing the length of that line work. Just like before, we can go and change the text height, we can rotate it, we can customize what layer it's on, customize the format, very simply and easily to generate cadastral information around our site. Now, for a more extreme example here, we could choose this more complex shape. Now, this is on the foreshore of Auckland. It relates more to the Queen's Chain, the boundary. But just to show you the power of these tools, we can grab anything that represents a parcel or a boundary and use that style, that line label style, to annotate the bearings and distances on all that line work. So from vector point to vector point, it can be done using these powerful BricsCAD tools. So that was just showing you how to generate some surfaces for the site and work with some of the powerful information, documentation information based on the GIS data. We're now going to move on to the third and final part of our presentation, touching on some of the civil design tools. The first one we're going to start with is corridors, so roads. And this is where you can use alignments or string data to generate a corridor based on a template on top of a tin surface. Once you've got this set up, you can modify that template. You can modify the string, the alignment, and it will follow that information. And you can very quickly use it to provide road information inside of your BricsCAD environment. Here, I've just done a quick attach of the aerial image to our tin surface. And I want to generate an alignment on top of that tin. So this is just a very basic way of doing it. But once you have these points being entered, these station points being entered on top of this road, you can go into the line work and the curb work and adjust it more accurately in the properties. Again, this is just a very basic demo, but we can turn off the information we don't need to see here. So we're just going to be working with the alignment. Again, that's following the tin surface. And we want to generate a corridor that sweeps along that alignment or that string. So I've got some templates that I've made previously. These are made from closed polylines that get converted into templates. And we pick that alignment and we sweep that template across the corridor, across the alignment to generate our corridor. Now we can also generate vertical alignment views and section line views. So once you've gone through and done this, you can then use the tools to, again, document your BricsCAD CAD file for faster productivity. So new inside of BricsCAD V26, inside the Pro version, you can start to generate cross sections on that corridor at different intervals, and you can customize them to the standards you need for your documentation output. It's instant, and as soon as you change the corridor template style or the alignment, the generated sections will update inside of BricsCAD. So in this simple demo, I'm just going to choose that basic corridor we created from the alignment and choose section lines. We simply choose the lines and hit return. And here we have the alignments available inside of our drawing. And then here are the section line information defaults for us to work with. So just like the annotation tools that I showed for lines and label styles, you can adjust what layers are going to be on, where they're going to start. So in this case, starting from the first part of the station to the end station. But again, you can choose different stations and you can choose different increments across that station. We've just chose the default 20 meters. So here it's run along that alignment and it's got those 20-meter intervals that are generating 2D sections off that 3D geometry. We now want to generate section views. I'm going to choose them all. There's some options here for the style. You can go in here and customize that style, adjust the settings, the labels, how you want the horizontal and vertical axis to display. Once you have this done, of course, you can then use it again in a template to speed up your BricsCAD documentation productivity. Here, I'm just going to place the section views outside of the site, and I have over a dozen section views generated instantly off my basic corridor. So this is new to V26, and we've made some enhancements in the latest release of V26.2. For grading, we've got some very simple cut and fill tools to generate grading. We can work with lines, polylines. We can adjust the pitch of the slopes for the cut and fill instantly. We can also look at elevation and slope information. And we have statistics and analysis reporting as well. You can generate tables and you can extract data out of the file as a CSV file for use in other applications. Now, the basic one I'll be showing today shows a polyline and the grading tool cutting in or filling on top of the tin surface. So all I do is I have that polyline selected. I choose the grading tool, I choose the tin surface, and I instruct it to go over the entire length of that polyline. It's showing here the angle, the slope. I can adjust it to be 15 degrees. And here we have some fill information. And over on our properties, we can also start to look at data regarding that fill. Now, if we want to choose a cut, we can grab that polyline again, go to our properties, and adjust its Z value. So at the moment, it's close to the shore. It's sitting 11 meters above sea level. We're going to drop it right down to 3 meters, and this is going to form the part of our basement for our site. Now, the original slope was set to 15 degrees. Not a problem. We can go to the properties and change the cut and fill slope to 70 degrees. You'll see it's gone and created that slope, and we can go to some of the visibility tools to better display more information about that grading tool. So we can show contours, triangles, points. We can adjust our major and minor contours. And we can also go to our grading settings down the bottom here and turn the infill and boundary on, and that will now cut our tin surface. Now, we can report out from here, but if you just want to see the cut and fill grading stats, just expand it, and we can see here that the cut volume is showing as 6,747 cubic meters that were done using the grading tool inside of BricsCAD Pro. Now that we have the grading tool and our site set up, I want to show some of the basic tools inside of BricsCAD BIM. Now we can X-reference in these files should we want to keep the civil file and the BricsCAD BIM file separated just for managing different tools. Within the BIM environment, we can simply set up our BIM workspace and convert some of the CAD data by using the BIMify tool. We can set up layers, we can BIMify, and we can very quickly create a BIM component for our civil site design. Now, this workflow I've just set up 3 levels, and I'm just using some basic out-of-the-box tools inside of BricsCAD BIM. I'm going to be working with CAD data, so I just have a polyline, a square polyline, which is my reference, generate a slab very quickly, and I can go and generate a retaining wall. Now, this is the out-of-the-box database. We can customize this as needed. We can choose entities, single walls. I just want to delineate around my site, and you can see that the walls have cleaned up, and we now have 2 3D BIM components built on our level 1. I next want to look at creating some retaining wall piles. So you can do columns and beams inside of BricsCAD. I'm just going to do a concrete reinforced bit of piling work here, but I don't want to manually place them into the model. I want to just place one of them and set the offset. So if we were doing this on a real site, we would drive or drill the holes for the piling into the ground, and they would be offset away from the retaining wall. So here I've done that using the tools inside of BricsCAD BIM, and now I want to array them around the perimeter of those walls. I don't need to manually do this. Again, I just use that CAD data as my reference path, use some default settings, and now I have my piles going around, arrayed around those walls, and I have the basics of a foundation of a basement set up using the BricsCAD BIM environment. Next, I want to add a few more items. So because we're looking at the civil site design, maybe there's some underground services, some underground pipes we want to connect up. Now, you don't need to be an expert or load in a massive database. You can work with 3D polylines to generate your pipe work. You can use the existing library inside of BricsCAD Pro, or you can add your own profiles and you can customize and modify the parts and materials as required. So for this particular demo, I have my retaining walls and my piles that I've just done in the other basic demo. And I have a couple of 3D polylines I want to use to form the basis of my pipes. In the structural MEP tab, I can apply a profile to that line work. Now, this can be done for pipes, it can be done for steel beams, it could be done for even HVAC systems. The simple one for underground services is, say, a supply or large concrete drainage type pipe, as per like my stormwater pipes, for example, or my sewer pipes. Here, I'll filter through the categories in my profile database, standard pipe, and I can choose to duplicate one of these or create a new one, or I can use some of the ones that are in the database here. So I'm just going to use one of the larger diameters. And when I choose that, you'll see in the graphics here, the radius of that pipe, the wall thickness of the pipe, and the materials. Instantly, it's generated a pipe that has been swept along that 3D polygon. And then when I accept it, it also goes and adds the corners, the final junctions for that pipe work. So again, it's a simple way for any user to leverage a CAD package, generate BIM components without having to be an expert in a new bit of software. Now, finally, to sum up, if you do want to do more advanced workflows with the BricsCAD engine, here in Australia, we have a partner who's developed a tool called Civil Site Design, which allows you to do a lot of work, a lot more advanced work in stormwater pipe design. It's got an AI project assist tool and a subgrade model manager. So for pipe work, you can set up all your stormwater pits, your culverts, your pipes. It's even got a clash detection tool. You can set your slopes and your falls all underground using the Civil Site Design add-on. It also has a little AI project assist tool, which will allow you to go through and check some of the components that have been added to your model. The project assist will recorrect things and build things as required. And you can see over on the right-hand side, the AI assist features. Now, I showed some basic corridors, but inside this application, there's some really powerful tools for doing much more detailed profiles to sweep along your strings and alignments. And finally, it's got a nice vertical grading editor. So if we've got a vertical representation of our road and we use the pop-up engine that they're built on top of BricsCAD, you can instantly make changes to those vertical alignments and generate them inside of BricsCAD, as can you do with the 3D corridor geometry in the subgrade model manager. So please check out this tool, Civil Site Design, built on top of BricsCAD. It will enhance your civil survey experience. So to summarize, we've gone over 3 core parts in this webinar. Number 1, we reviewed data, so how to do your geographic location setup, how to coordinate CAD GIS data against BIM coordinates like a program like Revit, and how to work alongside in a common data environment like the construction cloud using the BricsCAD desktop, BricsCAD files inside a desktop connector. Number two, we went into doing site creation with tin surfaces via point clouds and contours. We also touched on some of the powerful annotation tools for documentation for symbol styles, lined, area, and boundary labels. And finally, we touched on some of the tools built into BricsCAD that allow you to do corridors, grading for your cut and fill, and basic building information modeling, as well as the civil design tool built on top of BricsCAD Pro. With that, I want to thank you for attending the webinar, and we will open up the floor to Q&A. If we don't get round to your Q&A, please scan the barcode here, and we will connect with you to try and answer your questions and help you with your BricsCAD experience.
Thank you, Mr. Simon. Now, this forum is open for question and answers. Participants, those who have any question, they can type in the message box their questions. Find that
Yep.
no questions will not.
Smooth.
Yeah.
So I'll work through the Q&A. I'll read these out and answer them as we go. Yep.
Yeah.
Number one. So I'll just move my Zoom controls out a little bit.
No, there is no such questions actually. No question on the subject. So I think there is no question. There are only few elementary comments are there. If you have any questions, just given this QR code, you can scan
the QR code. Yep. So can you still you still see my screen?
Yeah.
Okay, I'll just move some things around just so I've got a bit more space. So there's the QR code that's showing. Okay.
Yeah, it's okay. So
Okay.
I think so there are no questions. You can change this with a vote of facts.
Okay. So
We are at the end of the
So I'll just work through the Q&A here. So OpenRose Designer, how can OpenRose Designer be utilized in a BIM environment, and what are the main advantages of integrating BIM workflows for highway projects? So thank you for the question. What I've found in the past is there'll be structural engineers doing bridges or other structural components inside of other applications. So it might be Revit aligning with another CAD application. It might be an IFC workflow or a CAD workflow. What's great about BricsCAD is you can have everything in the one CAD environment, and you can work either with the BricsCAD BIM tool and the civil tool, linking into the same package with no conversion, or you can leverage some of the add-on tools to do more with the structural components of BricsCAD BIM. Again, if you're working in BricsCAD Pro and the structural engineer is using Revit structures, you can still collaborate via the IFC workflow that I shared. We have a question on the size in full screen, small fonts. Yes, so we'll be recording this, and it'll probably be easier to see once you look at the recording. It probably requires some customization to adjust those fonts to make it bigger for the webinar. It's just the way the command prompt works. Moving on to point cloud data. So it's not restricted to New Zealand. Point cloud data is available for the entire world. It just depends on what's been made freely available by that part of the world. So certain countries, councils will share freely LiDAR data via the drone scanning or the UAV scanning, and it'll be provided on the Open Topography website. Again, if it's a restricted part of the world, maybe that data might not be available, but I encourage you to go and check it out and see what you can download. You could also work with the DEM data, the digital elevation modeling data, which now works in BricsCAD v26.2. So next question is the same thing. So it's not restricted, open topography. You can use it anywhere in the world. Structural analysis. What does structural analysis using BIM alongside Revit? So for structural analysis, we'd recommend a third-party application. So if you go to the BricsCAD add-ons website, you'll find that there's numerous tools like Parabuild, for example, which you can get on top of BricsCAD, and that would have an analysis type tool. Again, the analysis will come down to where you're working in the world, what type of code you need, but the data is usually transferable, so you can send that data between different packages, and because CAD is so universal, you could send it into another structural analysis program. Okay, next question. How many major percentage of engineering architecture companies have migrated to BIM from standard CAD? How do you see BIM software in the future of growth? So this is going to depend on what part of BIM you're using. In Australia, more architects predominantly use Revit because Revit was designed initially for the architecture community, and then they brought in structure and then MEP. However, the BricsCAD BIM environment, or the Hexagon engine or Octave engine now, it has numerous tools built on top of BricsCAD that are heavily used in the utilities and industrial engineering space. So BricsCAD will do some basic BIM modeling work for structural engineering, or there's bolt-ons like Parabuild. However, if you're wanting to do other types of structural engineering BIM, I would encourage you to look at the Octave website, where there are numerous engineering tools for various large-scale engineering industries built on top of a CAD package. Okay, I think that is most of the questions. I'll just pause. I know Claire's answered a few. Is there any that I've missed, or another one's just come through? Go. One more. So let's bring up the slides. So another new question. Thank you. So is point cloud and LiDAR tin model available in light versions of BricsCAD? No. We encourage you to get the pro version to benefit from all of these tools. The light version is fine for just doing your 2D workflows. One of the advantages that the light version does have is it's got the Lisp editor. So if you've got Lisp routines, you can benefit from that in the light version. But to use some of the powerful tools like the Civil Explorer, the BIM modules, the point cloud, the tin creation, the pro version is fantastic. So I strongly encourage you to go for the pro version, because it's going to save you a lot of time in productivity, interoperability, and documentation. Okay, I'll just double check the answered ones. So thank you, Claire, so much for answering. We had a few questions there, and I think everything's been captured. And this will be available on YouTube channels. And I apologize for any echoes, but hopefully it will be a little bit better in the recording. And thank you for the last question, last note. I'm happy to know more about the software. Thank you for the briefing. Thank you very much for attending. Yeah, we did touch on a lot of information in a very light way, but the goal of this webinar wasn't necessarily training. It was to explain to you some of the powerful tools inside of BricsCAD Pro and BIM that could help you be more productive in your profession.
Thank you, Mr. Samuel Nakista. And we come to end of a very interesting session. You have explained the workflow in a very basic way, the practical demonstration also. I also extend my heartfelt thanks to Ms. Claire for her presence and coordinating the event. Also, I express my thanks to all the participants for whom we are already having this session. Once again, I say thanks everyone for being here. And we look forward to organize such event, more such events. So that's all. I hope you have replied to all the questions. No more questions in there. So we are ending today's session.
Thank you. Thanks, everybody.